Hi, my name is Øystein Grøvlen, and I work on MySQL at Oracle. In this presentation, I'm going to talk about JavaScript support in MySQL 9.0. JavaScript applications are very popular. You can find them both in the front end, like browsers and so on, and in server-side applications, like, for example, Node.js. And it works great with databases. You can use a connector to a database, and then you can access data in the database, update the data, and so on. However, if you have very data-intensive use cases like data validation, JSON document processing, other string processing and formatting, or data cleaning or data transformation, this requires that you move data from the database into the client application, and then you store the data back into the database. This has some cost. Often, to process the data on the client side, you will need more resources, like, for example, hardware, to do that. And if you are moving data between clouds or out of a cloud, you may have to pay extra money to do that. There will also be extra latency by moving a lot of data between the database and the client and back. You need to serialize the data, then transport it over the network, then deserialize it, and do the same to send it back to the database. And if you have a chatty application, maybe you need several round trips to do the processing. Also, sending the data over the network exposes the data to extra security risks. An alternative is to handle the data-intensive functionality in stored programs inside the database. This will minimize the data movement and reduce the cost. And also you get improved security by keeping the data always inside the database. And also, in many cases, it will simplify the transformation of data by doing it inside the database. MySQL has for a long time supported stored programs in SQL. However, there is some limitation to such programs. SQL stored programs, the language is not as expressive as many modern programming languages. For example, it does not support containers like arrays and maps. It does not have many other modern language constructs that you, for example, can find in JavaScript. The SQL code is interpreted and not compiled into native code, which means that it is less efficient than executing many other languages. Also, there's a limited development ecosystem for SQL stored programs. There's less support in editors and debuggers and testing frameworks. It does not exist. And there's less possibilities to reuse third-party libraries in SQL stored programs. And also there's a limited number of programmers that actually are able to write SQL stored programs. So it can be difficult to find the necessary programmers to build your applications. So we are introducing JavaScript stored programs in MySQL. They are just like SQL stored programs, but now you can have a better developer experience. And as JavaScript is already run in browsers everywhere. It has built-in security features, and it also has more optimizations of the JavaScript code, and this will be is available now both in our cloud service in OCI, AWS, and Azure, and in the MySQL 9.0 Enterprise Edition. So why have we chosen JavaScript? JavaScript is one of the most used languages by developers. And almost all web pages uses JavaScript. It is supported in all the major browsers, and you have server-side runtimes like Node.js and Deno and others that can be used to run JavaScript programs on the server. There's a big ecosystem for development. There are millions of packages that you can freely download and use in your JavaScript development. And there's many millions of users that use these packages, the npm package manager, for example. So there's a lot of programmers available that knows JavaScript compared to SQL stored programs. So what is Graal VM? Graal VM is a Java VM, a high-performance Java VM that supports profile-guided just-in-time compilation. The JavaScript implementation is compiled into native code ahead of time, and it has a lot of advanced compiler optimizations that can be applied to the JavaScript code. The JavaScript implementation in Graal is based on ECMAScript, and the performance is competitive with the V8 engine. And the JavaScript support is implemented in the Graal polyglot framework, which can support multiple languages in the same VM. It has already official support for Java and WebAssembly, and there is previews available for Python and Ruby. Since Graal VM is a virtual machine, the memory is fully managed within the Java VM, which provides garbage collections and so on, and has a secure environment in which the programs can run. And it also has support for developer tools. So what do you need to do in order to create your own stored programs in MySQL using JavaScript? The syntax is simple, and is basically the same syntax as is used with SQL stored programs. The addition is that now you can specify a language clause with language JavaScript. And then you specify your JavaScript program using the as and then a string. The string can be single or double quotes, but since that often will conflict with the content of your JavaScript code, we have introduced a new string delimiter based on which we call dollar quoting. You can start your code with $2, and then comes the JavaScript code, and then you end with $2. And should there be $2 somewhere in your code, you can make a different delimiter by adding a tag within the between the dollar signs. For example, JavaScript or some other tag. And as long as you end the code with the same dollar quote, it is interpreted as the delimiter of the JavaScript code. The argument of the function, the argument names can be used directly inside the JavaScript code. For example, here we have two arguments, A and B, and these can be referred directly within the JavaScript code. And we support type conversion automatically between the SQL types and the JavaScript types. And most SQL types are supported, all the numbers like integer and floats, datetime, and other time variants, strings in UTF-8 and before, as varchar or JSON or text, and blobs. And in this example, we create a function that will compute the greatest common divisor of two numbers A and B. And we see that inside this JavaScript code, we use the math library, since GraalVM will support the standard ECMAScript library. And we can use that to use the absolute abs function to compute the absolute value on these numbers. And JavaScript stored programs can be used, or JavaScript stored functions can be used in wherever SQL stored programs can be used. For example, in the select clause, in the where clause, the order by clause, and so on. Here we use the function we defined in the previous slide in order to select all rows from a table called myTable, where the greatest common divisor is greater than 1, and we order it by the common divisor. You can also use it in DDL statements, as shown by this create table statements there, and you can use it in views and so on. And you can call JavaScript stored programs from SQL stored programs and vice versa. You can also use SQL inside the JavaScript store procedures. This is not only available in procedures, not in functions. So we support both prepared statements and ordinary direct execution of statements. There's to use SQL inside the JavaScript program. There's a session object. Sorry. There's a session object you can use that will map to the session of the database session of the caller of this procedure. So this means that whatever SQL you execute in this procedure will be executed in the transaction of the caller. In the first example here, we prepare and insert statements, and then we execute a loop where we compute a random number, and we using different functions from the math library, and then we bind this number to the prepared statement and execute it. So this way we can insert a number of rows into the table given by the row count specified in the input parameter. The second example, we do not use a prepare statement. Here we specify a SQL statement that is directly executed. And the result of the execution is stored in the result variable. And we can iterate over this result row by row to compute the average of all the age columns of all rows in the table. And this procedure cannot return a value, we use an out parameter to return the average age of all the rows in the table. One problem with SQL Store Program, as I mentioned, is that it's difficult to debug it. To try to give some debug assistance with JavaScript program, we support the console object. So you can add tracing to your stored programs by logging to the console. In this case, we are creating a procedure called divisions that divides two numbers, A and B, and put the result into the out variable. But then for each value of B, we will be checking whether it's 0 or not. And we can then log all the different values we are for each execution of the procedure, we log to console the values that of B that has been inputted. And if B is 0, we will throw an exception. And this exception will be converted into an SQL execution error, as we can see from the output below here. And whatever we logged into console can be inspected by using the MLE session state variable. You can look at what has been written both to standard out and standard error. And also, you can see the stack trace of the last exception that was thrown. Now I will show a more complex example of how to use JavaScript stored programs. And I found this package on the web called Validator that I can download and use to validate different kind of strings like email addresses, credit card numbers, and so on. I take this code and then I put it into my editor, and then I create a function header for my JavaScript store function. I call this function validate email, and then the input will be the email address that I want to validate. And then it returns true if this is a valid email address and false if it's not. And then I paste the entire code for this library into this function, and then at the end of my function I will call this library to validate whether the input string is an email or not. You see that validator here, there's many different things you can check for using this function, but my function will only check validate email addresses. So let's see how we can use this function. So if you are using the MySQL Enterprise Edition, we will first have to install the component. If you're running it in the cloud, this has already been done for you. Then we need to create the function. So we just read the file that I created to create the function. And now we can start using it. And we will be using it on a database, airport database, which has a table called passenger details. We can look at how the first part of that table. So you see that it has different kind of passenger information, and it has an email address column, and we will check whether there is any invalid email addresses in this table. So first we just check, since this is a large table, we can just check whether there's any invalid email addresses for passengers from Norway. And we see here that there are 12 invalid email addresses. We can see if we can count how many email addresses there is in the invalid email addresses there is in the entire table. Since the table is big, that will take a bit of time, but while we are waiting for that, we can look a bit at the invalid email addresses we got from the previous query. We see that some of them, they are lacking the last part. There's only one part after the @ sign, and there's other that has 2 @ sign, and so on. So it took 16 seconds for us to execute the entire query and see that there are 2,470 invalid email addresses in this database. So now, when we executed this execute this function very many times, just-in-time compilation has started. So if we execute this one more time, it should go faster, hopefully. Yes. No, it executed in 8 seconds. So it has been executed in half the time after just by using just-in-time compilation. So let's talk a bit more about how this feature is integrated into the cloud service. So JavaScript Store programs will work seamlessly with all the other server components that are configured on the cloud service, like the InnoDB, storage engine, use of HeatWave, Lakehouse, AutoML, replication, and so on. And with respect to security, Graal ensures that the code that is executed is isolated from other concurrent executions. So you will not be able to access the context of a different database session or see any data from it. It also attacks against attacks like JIT spraying and side channel attacks and so on. And the sandboxing feature of Graal VM ensures that the programs, the JavaScript programs, does not have any unauthorized access to file system, cannot spawn new threads, cannot access the network or execute code outside the VM, and so on. And also, the same privileges are used for MySQL stored JavaScript program as for SQL programs. You need to have the privilege to be able to execute a JavaScript stored program. And you can also decide whether the execution of the program should be using the definers or the invokers security context. The memory and compute resources to be used by for executing JavaScript programs are configured based on the size of the cloud instance. And as long as you do not execute any JavaScript, there will be no resources allocated to this feature. And how much memory is can be used is controlled by the Graal VM. So you cannot use more memory than is allocated for the Java heap. And inside the heap, the Graal VM will ensure to do garbage collection of memory that is no longer used. And since this is integrated with the MySQL Enterprise thread pool, there's a limitation on the amount of concurrence you will allow for concurrent execution of stored programs. And this is also automatically configured based on the cloud shape. There's also a MySQL status variable that you can use to check how much memory is used by the JavaScript execution. So with respect to performance, as the VM that is used for MySQL is custom built based on the native image feature of Graal. And this VM is then configured and optimized for the cloud instance. And as we already have mentioned, Graal VM has a lot of optimizations that will ensure that the efficient execution of the JavaScript programs. So the key takeaways from this presentation is that by using JavaScript, you are able to express complex logic within the database, and you can push part of the data-intensive application to the database. By using JavaScript, you also avoid that the vendor locking, since the JavaScript syntax is standardized and not depending on different SQL dialects. You also get all the Graal VM enterprise optimizations at no additional cost, and it integrates well with all the existing cloud features. Thank you for listening to this presentation, and hope you will start using JavaScript programs.